Let's jump in. Thanks for joining us for local development techniques with Kubernetes. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. It will only be live demos. We're going to look at a bunch of tools that will allow us to work with containers rather than assuming it's a downstream concern that's somebody else's problem. We're going to look at tools that will help us in our local inner loop. All the tools that we'll look at is here in this gist. And yeah, that URL is really long. So let's head over to robrich.org and click on presentations. And here's local development techniques with Kubernetes here at NDC Sydney. You can click on this link and that will get you straight to this gist really easily. While we're here at robrich.org, let's click on About Me and we'll learn some of the things that I've done recently. I'm a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Sydney or wherever you're connecting from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I do a lot of Docker and Kubernetes training and consulting. If you have that need, I'd love to help. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. And if you'd like it, no, I'm just kidding. Yeah, Richard Campbell is awesome. So let's dig in. Now, I have a bunch of things where we're going to look at ways to start containers differently, to be able to visualize container contents, visualize cluster contents, and finally debug inside of containers. Let's start in. I'm going to cd into one, and let's take a look at this inside of VS Code. I have this Docker file here, and it references my server, my node code right here, and I'm getting ready to build it. Okay, so now I need to say Docker build. I need a dot for some reason. Let's tag it. Oh wait, the T doesn't go there. It goes over here. Hello, node v0.1. Once I've got that built, now I need to run it. Docker run hello node v0.1. Do I need the dot? No, I don't. I do need a -p. Oh wait, that doesn't go here. It goes over here. We're spending a lot of time thinking through the process of building and running a container. Instead, let's pop open this Docker Compose file. Now, this definitely is the simple one, just to kind of get a feel for what we're going to do. This Docker Compose file allows us to capture all of the build and run details here in one file. Here's hello node, here's the dot, here's the ports that we want to map. Oh, I completely forgot about setting that environment variable. Now when we're ready to go, we can say Docker Compose up. And in this case, because the container doesn't exist yet, it's automatically going to build that image straight away. And then it will start the container. Now I can just come up to localhost 3000. And so let's come to localhost 3, not that one. Localhost 3000, and we can see the website is running. Now, if you're familiar with Docker Compose, maybe this is old hat. Let's hit Control-C and let the website come back down. But let me show you one trick that is pretty interesting here. Network mode of bridge. Now, by default, when we start a Docker Compose file, it will start a separate network. Now, that's great in ensuring that the containers that we start here don't interact with the containers that we start in a different file. But what if we have a Docker Compose file for our backend and a Docker Compose file for our data stores, and we're debugging the front end? Well, we want the backend and the storage to be able to communicate together. So let's use network mode of bridge in all of the places. And now it won't create a separate network. And the containers that we start in various Docker files will be able to communicate with each other. That's perfect. So now we do a Docker Compose down, And all of the details about running and starting are now solved in that Docker Compose file. We don't need to remember that. We can instead focus on accomplishing the business logic for our users. Excellent. Now, Docker Desktop is a great mechanism for being able to run both Docker mode and Kubernetes mode. We come in here to Docker Desktop, we turn on Kubernetes mode, and we have a Kubernetes environment. But what if we want to run differently? Let's talk about Minikube. Minikube is an alternate Docker runtime that allows us to run containers just as we would, and also gives us a Kubernetes environment as well. So I come in here and I'll say Minikube start, and I've already done that in this case. So we can see that we have this virtual machine running with Minikube already set up. Now in this case, I chose to run it on Hyper-V, but if you're on a Mac, you can run it on HyperKit, and you can also run it inside of WSL. Now you'll notice that I also have other virtual machines for other Kubernetes clusters that I wanted to run. If I wanted to run my Linkerd demo, I'll run it in this one, and my Istio demo I'll run here. Now, these clusters won't collide because they're separate spots. Now, one of the things that people often ask me about is when I'm doing Docker training is, well, where are my volumes stored? And when you're running Docker Desktop, all I can say is, they're in here. Docker very specifically excludes us from that so that we don't mess it up. But with Minikube, it's the internals exposed, batteries included version. So let's do this. Let's do Minikube SSH. Now I'm inside that virtual machine. And the cool part about being inside that virtual machine, sudo su cd var lib docker ls-l. When people ask me where are the Docker volumes now, they're in this folder, and you can go now traverse it and go wander through it. You can also apt-get install content. This is the batteries included internals exposed version. Now, some of the niceties that Docker Desktop gives us, like automatically proxying between localhost and the virtual machine associated with Docker, those things don't apply. So if I want to map volumes in, I need to first create a proxy between my local machine and a particular folder inside that virtual machine. And instead of connecting to localhost, I will connect to this IP address, or I'll just use the host name of Minikube. Now that's great. Now that I've got that environment set up, let's do a Minikube Docker env, and I'll tell it my shell is PowerShell. There's an open bug that allows it to, it automatically detects PowerShell and command prompt and terminal on Mac, but there is a bug that doesn't allow it to yet detect PowerShell core. So once I've set these environment variables, now I'm able to run all of my standard Docker commands like I did before. Docker image list, and we can see the content. In a similar way, I could open up a command prompt, and I could say Minikube Docker env, and it automatically creates, instead of PowerShell environment variables, it will create Windows command prompt environment variables. Or it will sit here blinking. There we go. So I set these environment variables, and now Docker image list, and I can get at the content here as well. Now, it is the batteries included internals exposed version. So if I say Docker container list, by default inside Docker Desktop, we have this checkbox that allows us to turn off the Kubernetes containers. We can choose to turn it on to expose it, but in Minikube, it is exposed automatically. So which containers did I launch? Well, I noticed that all of the Kubernetes control plane pods start with k8s_pods. So I could say Docker container list, and I will pipe it to grep-v k8s. Now, I only list the containers that I started, and in this case, I haven't started any yet. That's perfect. So Minikube is a great way to be able to start containers differently. Now, Docker Desktop definitely is the easy button, and we get automatic network proxying and all kinds of interesting things there. But Minikube allows us to do something a little bit different. Minikube is great at running in nested virtualization scenarios, for example, where Docker Desktop just says, hey, you're inside of a virtual machine, I'm not going to help. So if you're inside nested virtual machines, then you might consider running inside Minikube. Once you've got it going, you have an identical Docker and Kubernetes environment, just like you did with Docker Desktop. Next up, let's take a look at Docker Watch. Now, I would really love to be able to say Docker Watch and have it automatically rebuild my image anytime something happens. Well, that isn't a command, but let's take a look at Scaffold. Now, Scaffold is an open source project that allows us to automatically rebuild our image, optionally push it to a container registry, and start up our content inside of Kubernetes anytime code changes. So we'll start with a Scaffold init, and that will get us this YAML file that describes the details. Now here I have this Scaffold YAML file. It has an image. Note that it doesn't have a version number, because as Scaffold notices changes, it will automatically rebuild that content. So I don't want to specify a version number here. But then here is my Kubernetes YAML file that will automatically start, and it just includes the normal content, deployment, service, and in this case, I didn't need an ingress. But here I do have a version number, and Scaffold will override that nicely. I have a Docker file that does all the things, so let's start up Scaffold. Scaffold dev, and now it's watching my content. So as it boots up, it will automatically notice that I've got some content. It will go rebuild my image. That's perfect. And it will start to push that into place. Now, because it's running in Kubernetes, kubectl get all. Let's take a look at what port it chose. There's that port. So we'll head off to, we're running Minikube. So instead of localhost, we'll use Minikube, and we'll go to that port number. And now we see our website. Hello world. Great. So now let's come in here and let's change the content. Instead of hello world, let's say hello NDC Sydney. I'm going to push save here, and we can see that it automatically starts rebuilding my image. That's perfect. Now, optionally, it can push it to a container registry, and then it will reapply my Kubernetes YAML file with the new image in place. I'm going to do a Kubernetes get all again, and we can see this one terminating and this one starting. If I hurry, I can catch it in the act, but let's push refresh, and let's give it a second. Since I'm screen sharing and all the things, then sometimes it takes a minute. Let's see if it will come back down, and then we'll refresh our web page, and now we get the new content. Perfect. Now I didn't need to do anything. I just pushed save in my code editor, and automatically the new content popped into place. Now I did need to push refresh in my browser. Maybe if I had an auto refresh in my browser, that might be really interesting. But Scaffold is a really great way then to be able to automatically rebuild my container anytime something happens. Now, it's not uncommon where I'm like, yeah, but it's just not building correctly. And that's where Scaffold will be perfect. Let's hit Control C, and now Scaffold is down. Next up, let's take a look at being able to visualize content inside of a container. Now, we've been working with the hello node image. So let's say Docker history, hello node. And we can see all of the commands that were used to build up this image. All the way back from the node base image that I started building on, all the way through all the content that I built. And we can take a look at the sizes of the various layers. But what content is in that layer? Did I build it correctly? Am I in the right directory? That's where Docker history really can't help us. But let's take a look at Dive. Now, Dive is a really elegant program that allows open source here up on GitHub that allows us to be able to visualize the contents of our cluster. We can cruise up and down through the layers. We can see the files that are created in each layer. So let's say dive hello node v0.1, and by default, it will try and pull it from Docker. In this case, it already exists, so it can pull it up just fine. I'm going to push tab and then hit spacebar to close some of these folders. Let's close this folder and this folder and this folder. Okay. Tab back to my list of layers, and this is the original layer. Next in this layer, the next layer will add the home and node directories. The next layer pulls in some yarn content. That's pretty cool. The next layer adds some stuff. I think it's down here. Yep, the user directory. And let's come up to the top here. And here's where my Docker file began. I created this app directory. One more layer down, and we can see that we populated the app directory. Now, in this case, we have our server.js as we expect, but we also have a Docker compose and a Docker file. That's not really what I want. It looks like I have a mistake in my code. I'm going to come back here into my folder, and I'm going to create a new file that is a .docker ignore file. Now, in my Docker ignore file, I want to specify all of the content. I want to ignore libraries that I download, so the node modules folder. I want to ignore built content. So in a .NET project, I would have bin and obj. In this case, I don't have any built content that I want to ignore. The dist folder is often in a node project. I also have user-specific content that I might want to ignore. star.user, the .vs folder, maybe the .vs code folder, the .idea folder. I also have log files and other content, so star.log. But in this case, I really wanted to ignore this Docker file and Docker compose file. So docker compose.yaml, Docker file. I might also choose to ignore the .git folder. Once I've built up this .docker ignore file, then if I was still running Scaffold, Scaffold would automatically rebuild my image, and now I wouldn't have that content in my container. Dive is really elegant at being able to see the contents of the files in the container. Did I put them in the wrong directory? Is that why my container isn't starting up correctly? Or did I include more content than I needed? Maybe my node modules folder is really full, or I have a step that copies in some libraries and then changes them, and so both layers are really big. That's really powerful to be able to visualize the contents of my container. I'm going to hit Control-C, and I jump back out of Dive. So Dive was great to be able to visualize the contents of a container. Next, let's look at visualizing the contents of a cluster. Now we can look both at the Docker mode of things, and we can also look at the Kubernetes mode of things. Let's first look at Docker mode. I'm going to start up. Let's take a look at Lazy Docker. Now Lazy Docker is an open source GitHub project that allows us to be able to visualize a Docker cluster. Now you can see them clicking around in this screen. If you're using a Mac or if you're using Windows Terminal or PowerShell, you can definitely click through. If you're using Windows Command Prompt, you'll need to use the key bindings to be able to navigate. So let's start up Lazy Docker, and we'll be able to visualize the contents of this cluster. So I'm going to click on the stats, and let's cruise through to a container that's running. I love these graphs of being able to visualize the content within the cluster. ASCII art to be able to do this. If you only have SSH access into your cluster, then this can be a great way to be able to see the content. Let's take a look at the images. Here's the image and the various tags associated with it. Yep, that's the one that Scaffold built for us. Here's the one that we built from Docker Compose. And we can cruise through the other ones. Here's our node base image that we started from. That's pretty cool. So lazy Docker is a great way to be able to visualize the Docker side of things from a command prompt. Let's also visualize the content using a UI. Next up, let's take a look at Portinger. Now, Portinger allows us to be able to visualize the Docker side of things. Portinger also has mechanisms for visualizing the Kubernetes side, but it's not quite as strong. So I went to the docs inside of Portinger and grabbed this Docker compose file. Docker compose up. Let's take a look at that Docker compose file. Here's that Docker compose file for Portinger, and we're binding to port 9000. And so let's go to Minikube 9000 and take a look at Portinger. Now our first step is to log in. We haven't set a password yet, so let's build ourselves a password. And now we're running. Now we could definitely connect to a cloud-based cluster, perhaps on Azure or AWS or GCP. We could also put an agent inside of our on-prem cluster. We could connect to a remote Docker environment, but in this case, let's connect to the Docker environment that we're currently running. Now it does say that we need to map the Docker socket into place. Now, pardon me, we'll want to do that carefully because the Docker socket allows us to make changes inside of our cluster. But here in that Docker compose file, we can see that we've already got that Docker socket mapped into place. That's perfect. We have a second volume that will save our password details. So if we log back in, we'll know that we're hitting the correct account. So now that we've got that Docker socket mapped, let's connect and let's dig into our local cluster. We can see the images that we've pulled, and yep, I've got a few. Here's the Hello Node version 0.1 that we created. We can take a look at volumes. I always like wandering through here and noticing the things that I forgot to delete, like this one. We can also take a look at running containers. Now we see the Portinger container that's running right now, and we can also add a new container. Let's go look for Hello. Oh, I love that IntelliSense. Let's go grab Hello Node v0.1. We can choose to expose all the ports, or in this case, I'm going to choose to grab a port specifically, 3000 to port 3000. We can also set volumes and environment variables and other details that we want in this container. And then once we've got it ready to go, let's deploy the container. And now we can see that container running inside of our cluster. There's the Hello Node image that it used, and we've got this container name. Now that's great. Digging into this container, we can take a look at some of the details associated with it. Here's the logs, the console logs, and it says it's running on port 3000. So if we come here to Minikube 3000, we can see that container is running. Oh, and apparently I'm not getting that text. That's interesting. We can also take a look at other details. Inspect is great. If ever you've done a Docker inspect and you have just a wall of config, I kind of like being able to open and close these details. One of the things I like to look at is the networks. In this case, it's got an IP address of 172.17.0.4. That's kind of nice. And wandering through the ports, it's nice to be able to scroll up and down and to be able to look at that content. Now, we were able to take a look at the configuration details. We can also take a look at the console. Now, this is an Alpine-based image, so instead of bash, I'm going to switch to ash, and I'm going to connect. If the only way that you can connect to your cluster is through a web browser, you can still get into your container. Now, I'm running on Windows, but this is inside my container, so dir isn't a thing, but I can do an ls-la, and we can see that content. Yep, I haven't rebuilt that container since we adjusted the .docker ignore file. And now I can say node server.js. And of course, that port is already in use by the process that's doing that. Let's do ps-ef. And we can see the original node process running inside of our container. Now, this can be really helpful if, for example, we want to say, did we start in the wrong folder? Did we copy the content into the wrong folder? Is our configuration not quite right? We do want to avoid changing our container contents. This is not the way to do last mile configuration, but we can take a look at our container and validate that our container is running as expected. Once I'm done, I'm going to exit out of here and I'm back to my web browser. Now we started a container on a cluster, and so you do want to secure your Portinger dashboard very carefully. Once we're done, let's remove this container. We could automatically remove persistent volumes. Let's do that. And now now we've stopped that container. Let's hit Control C, Docker compose down, and we'll take down Portinger. Docker volume prune. Yep, I had a few too many volumes kicking around. And Portinger was great at being able to show that. So we got to look at the Docker side of things. Now let's take a look at the Kubernetes side of things. Now Kubernetes is going to launch the containers, but it wraps them in this nice mechanism of pods. So let's start out by looking at this from the command line. Let's look at, here's Portinger. Let's look at K9s. Now K9s K9s is an open source project here that allows us to be able to visualize the Kubernetes cluster. Now it does look a lot like VI, work a lot like VI. So when we start K9s, then we'll use our familiar VI syntax. So I'm going to hit colon and I'll switch to namespaces. Now in my namespaces, I can cruise up and down. Let's dig into the Ingress Nginx one. We can see 2 pods have finished and 1 pod is running. I'm going to dig into that. We can see the 1 container there. Let's dig into that container. We can take a look at logs. In this case, the logs are pretty empty, so I'll back out. Let's take a look at, yep, there's the empty logs, and we can walk our way back out. I'm going to hit colon again and exit. And nope, that's not the command. Control C dumps us back out of K9s. Now that was a great way to be able to visualize the Kubernetes side of things. I like to switch back and forth between lazy Docker and K9s, depending on the type of visualization that I want to see. If you only have SSH access into your cluster, then these can be excellent tools. Next, let's take a look at a UI way of doing this. And I'm going to showcase Schooner. Now, Schooner is a free and open source project. Kubernetes does come with a dashboard, but authentication is not part of the Kubernetes dashboard by default. By comparison, Schooner has authentication turned on by default. So let's start the Kubernetes dashboard. I'll say kubectl apply Schooner, nope, -f, Schooner, and up starts the Schooner dashboard. Kubectl get all. Let's see what port we got chosen. Yep, 32,000. And let's head off to Minikube colon 32,000 and take a look at our Schooner dashboard. Now, by default, we are asked to log in. So let's go grab the authentication token. It's stored as a secret inside of our cluster, and paste that here. Now, I love being able to visualize my Kubernetes cluster this way. Let's take a look at the namespaces and the various content in each namespace. So here's the pod that's running and the 2 pods that have finished. We can dig into a particular pod and be able to explore its configuration. I like to come in here and take a look at storage and volumes, because it's really easy for us to accidentally forget volumes and maybe have them kick around for a long time. Another thing I love to look at here inside accounts, I like to look at secrets. Now, we're in the default namespace. Let's switch to all namespaces, and we can see that there are a lot. If you find a lot of secrets and you find that they're really old, it might be time to rotate some of those secrets. Now I'm going to switch to just the default namespace, and we'll take a look at the Schooner token that we have right here. Now this is the token that I use to authenticate. If you have access to the cluster enough to be able to see the secret, then you have access enough to be able to visualize it with Schooner. My cluster is running locally, so I don't mind showing you this token, but that's the token that I copied and pasted into place to be able to log into Schooner. But I can also look at other secrets in here as well, and that's really helpful. Once we've visualized our content inside of Schooner, I'm going to come in here to my profile, and I will choose to log out. Now, Schooner makes me log in by default. The built-in Kubernetes dashboard does not. It's really easy to accidentally flip it from a cluster IP to a node port and accidentally expose it externally. Much like Portinger, we could create content inside of our Kubernetes cluster, and so we really want to secure these dashboards carefully. Let's take down Schooner, kubectl delete -f Schooner, and now Schooner is not running as well. Next, let's take a look at debugging inside of our cluster. Now, I have this extra folder here called debugging. I'm going to open that in a separate VS Code in a moment. Let's take a look at how that'll work. Now, when we're debugging inside of Minikube, we are debugging inside of VS Code. VS Code will actually split in half. Now, there's half of it that's running inside of our UI that allows us to do theme extensions like our font choice and our color palette. The other half of VS Code is running as a server, and that's where our language extensions and our build and compile mechanisms work. Now, a port connects those together, and we have a volume mount that allows us to get the code into the container. Now that we've got VS Code split in half, we can work on our code locally and be able to get advantage of content that we may not have installed on our local machine. Now, the first step is to come in here to extensions and go look for the remote extension. Now, here's the remote containers extension, which very specifically powers containers. But there's also a remote development extension that includes both the remote containers extension and the remote WSL extension and a remote SSH extension. If you only have SSH access to your Raspberry Pi and you want to do some debugging on that, yeah, you can keep SSHing in and maybe using VI or copying content to and fro. But you can also create a VS Code mechanism where you run that server on the Pi and you're able to debug that content from VS Code locally. So I've got the remote development extension installed that gives me all three of these extensions. And with that installed, I now have this green button down here on the bottom right. I'll click on this green button and up pops this menu of being able to do really cool things. Here's the content inside WSL, inside SSH, but we'll focus on the container content. Let's start by trying a development container sample. Now, we're able to pick various technologies, and once we pick that, it will automatically spin up a container with that content ready to go. I didn't need to install this content. If I wanted to play with Python or with Rust, and I didn't want to install those compilers, or maybe I want to go try some Java stuff. Will my content work if I upgrade to Java 11 or Java 13? I don't know. Let's run that in a container where we don't have any conflicts. When we get ready to install this in our local content, let's pop this open again, and we can say add development container configuration files. This allows us to automatically scaffold content in our language of choice to be able to put the content necessary for starting up our system. Now, I've already got this content installed. Let's open it up inside of our second VS Code, and we'll be able to start debugging this content. Now, I have a .dev container folder, and inside that, I have a devcontainer.json file, and that's the content that we need for VS Code to recognize that this is debuggable inside of a container. Once it starts up, in a second, as it activates all of its extensions, it will pop up a dialog that says, hey, can I restart this inside of a container? Yes, please reopen that inside of a container. I also could have definitely come in here and clicked the box and said, yes, I would like to reopen in a container, but doing it automatically is actually really helpful. I love watching these logs pop up because it's really fun to see how it builds up the container, maps the volume into place, and automatically gets that set up for us. It will take just a second. Grabbing the local content, it looks like it gave it a name. That's great. And it looks like we've got our container almost running. Mapping that volume into place. Starting the extensions. And now I'm running. Perfect. Now this is running inside of a container. I'm here on Windows, but if I create a new terminal, I've got, not that one. Let's start a new terminal. Uname -a. I can tell that this is really inside the container. This is Linux. If I come back to my command prompt and I say docker container list, and we'll use our trick to get rid of all of the Kubernetes control plane. Here is that container. Docker container list. Helps if I spell container correctly. Here's that container that it just spun up. Now that's excellent. Let's close this and we'll take a look at the .dev container JSON file. Now our first step inside the dev container JSON file is either to specify an image or a Docker file. Now this Docker file is not the Docker file that we'll use to get into production, but rather the Docker file that we use to be able to set up our debugging container. So I have that here inside the .dev container folder as well. Now you'll notice that we're not doing any copies, we're not doing any volume mounts, we're not starting anything with CMD. This is just creating the environment that VS Code can use to be able to set up our environment. Now in this case, I used Node Alpine and I specified the workspace directory. I also installed Git and curl in case I wanted to do any source control actions here inside the container. Now that we've got our image or our Docker file, then we have a post create command. Now I wanted to npm install inside the container. Now I didn't want the Windows versions of any native modules. I wanted the Linux versions of it. So after the container starts up, it will do an npm install to be able to get all my dependencies. Now I can specify various settings that I want. Do I want to include various extensions installed inside the server side of this? In this case, I just chose big font sizes. We can also list the forwarded ports. VS Code is really good at discovering when we launch ports, but in this case, I'm going to very specifically call out that my port is 3000, and it will automatically proxy it back to my machine. So it won't be Minikube 3000, but rather localhost 3000. That means if we're using this technique inside of Azure or inside of AWS, then we won't be hitting an AWS URL. Rather, we'll be hitting localhost to be able to tunnel through into our debugged container. Now I am running inside of Minikube, so I do have to specify the workspace mount, and I have to specify that I'm mapping this folder from my PC into that VM, and then map it from that VM into the container. Now that we've got that content in place, let's start debugging our system. I'm going to create a breakpoint here and a breakpoint here. And just like I would in any environment, I've got my .vs code folder, and so I can start debugging. Now the cool part about this, we see that we've got syntax highlighting, we've got a normal type of run environment. Yep, we hit our breakpoint straight away. Oh, would you like to open it in a browser? Why, yes, I would. Notice that it's localhost 3000. We're proxying from the VS Code through that socket into the remote container. Now we're still at our breakpoint, so we can, I'm going to take off this breakpoint and push play. And now we'll get to our first breakpoint in our code. Let's take a look at the request. Much like we would if we were debugging anywhere, we can wander through the variables that we have set. Here's the URL, and in this case, it's a /. Excellent. Now I can take a look at various variables. I can step into with F10, step over with F11, or no, step into with F11, step over with F10, and do all the debugging that I need to. I'll push play, and the next request we'll see will not be the /, but this one rather will be looking for the favicon.ico. So, yep, we're looking for favicon.ico, and I'm able to debug my website in the ways that I need to. I'll take off this breakpoint and just push play, and we can see the content pull up inside of our container. Now, the cool part is it is just regular VS Code. And so I can do regular IntelliSense and content here, but we do have VS Code split in two pieces. One is running on my local machine to be able to give me the colorization font choices. The other part is running inside the container that gives me that syntax highlighting and debugging experience. Once I'm done here inside the container, I'm going to come into this green spot and I'm going to say close remote connection, and it pushes VS Code back into normal mode where it joins those two pieces, and I could open up a different project. Now this has been really cool, being able to visualize content inside of a container, visualize clusters in interesting ways, to be able to visualize, to be able to debug inside of a container, and also to be able to start containers easier. You can take a look at all of the tools that we've seen here on this gist and grab this gist really easily from robrich.org, or I'll put a link here in chat. If you're watching this video later, hit me up on Twitter at @rob_rich. I'd love to learn about the tools that you really enjoy and how I can incorporate them in this talk as well. For those of you here live at the event, one of the questions I often get here is, well, does this work in my cluster? What if I'm on AWS or OpenShift? All the tools that we looked at today are very specific to Docker and Kubernetes, and will work on any flavor of Docker and Kubernetes. You can use Minikube to debug locally, or you can use K9s to be able to visualize your OpenShift cluster. You can use Lazy Docker to be able to visualize both your local Docker desktop environment or maybe a Docker Swarm instance. None of these tools are specific to or borrowed from any particular cloud vendor. One of the tools that I wish I had time to explore is Helm. And I actually originally included Helm in this talk, but Helm grew out of it. And so I have now a completely separate talk that discusses how wonderful Helm is at templating content. If you get tired of all the duplication inside of your Kubernetes YAML files, then Helm could be a great choice at removing that duplication. Well, this has been a lot of fun getting to show you local development techniques with Kubernetes. Grab me on Twitter at rob_rich if you find some concerns, maybe later today, or if you're pondering on this tomorrow or next week. Thanks for joining us today.